All right, to reviewing some important stuff that we learned in Algebra 1, but I want to make sure you've got before we jump right into using a way. Sorry, I'm showing my colors here. I know you can see that. All right, so you should have the guided notes in front of you. If you do not, pause this and go get them, or if you have lost them, then I guess get out a separate sheet of paper. You must have your problems written down if you want to get credit for doing your homework. So please, please, please make sure you have this written down, preferably on the piece of paper that you were given. If you were absent, then on your own piece of paper. So the learning goals we're trying to hit, we're trying to make sure we can solve absolute value equations and graph their solutions, and that we can rewrite and solve absolute value inequalities and graph their solutions. Now, you've learned all of this in Algebra 1, but you may not remember some of it. Hopefully you remember parts of it as we go along. It should at least feel a little bit familiar. So some hints to remember when we are dealing with inequalities. When you are multiplying or dividing by a negative number, you must flip the symbol. Now this applies only to inequalities. Obviously you can't flip an equal sign. But what I mean by this is if, let's say, you had negative 2x is less than 4. If you were going to solve that, you would divide both sides by negative 2. And when we write our solution, we have to flip the symbol in the middle. Because we divided by a negative, that would become a greater than, and then 4 divided by negative 2 would be negative 2. So make sure you flip the symbol anytime you multiply or divide by a negative. Don't go like all extra crazy and every time you see a negative start flipping things. It's only when you multiply or divide by that negative. Second rule to remember, that when you switch sides for the variable, you have to flip this symbol. And it's kind of weird. I don't know how to word that any better. Maybe you can come up with something. But what I mean by that is if you solve and you end up with something that looks like this, 5 is greater than x, we are going to want to write our final answer the other way around. So with the x on the left and the 5 on the right, but when you do that, you have to flip the symbol as well. These mean the same thing, but most of you, when you learned to graph absolute value inequalities or just regular inequalities, you learned rules that had to do with this variable being on the left side. So I've just found over the years that people who leave it like this usually graph it wrong. Now, if you're in that small percentage of people who just know their stuff that well and you leave it like this and you're going to graph it right every time, have at it, go for it. I'm just always going to do this so that most people know what I'm talking about. When we graph the less than and greater than symbols, when you have those, we are going to use open circles. When we've got the little equal signs underneath, so less than or equal to, greater than or equal to, those we are going to use closed circles for. So the way I remember it is these symbols have a little something extra. They've got the equal underneath. So the circle needs a little something extra too. We're going to fill it in and make it colored. So we color it in, we close it if it's got the something extra. If it doesn't, we're going to leave it open. It's going to look just like this. All right. The rest of them are hints for how to set the equations or inequalities up, and I think the best way to deal with that is to just learn them or review them rather as we go. So I'm going to start just with the first one, and I guess I probably should have written, this is probably the most important thing, so maybe I'm going to put a big old star next to it and put it at the top. And that is that you must get the absolute value term alone first. And that is before You do any of these things. So if we look at A is an equation. So we're going to have a really simple rule that we're going to fill in this lovely blank for how to deal with absolute value equations. But the key is that we can't apply that rule until the absolute value term is alone first. So here's my absolute value term, the 5x plus 1. It's not alone because it's got this pesky minus 5, so I need to get rid of that pesky minus 5 first by adding it to both sides. And I think we're pretty good with knowing what to do with how to get variables alone. But now I'm using it to get an entire term alone. So now my equation is changed to the absolute value of 5x plus 1 equals 24. Now that my absolute value term is alone, I can apply my rule. And the rule for absolute value equations is that we're going to turn it into two separate equations. One is going to be just like the original, except without the absolute value sign. So I am essentially going to copy exactly what I had in the step above, except no absolute value signs. So there we go. Then between, I'm going to write and the other one is going to be equal to the opposite of the original. So that means the left side is going to stay the same. It's still 5x plus 1. But instead of equal 24, it's going to be equal to the opposite of that, which is negative 24. Once I've got that, I think most people are pretty good with how to solve this from here. You solve both of them separately. So subtract 1 on both sides. That gives me 5x equals 23. Then divide by 5. No, that does not come out evenly. Yes, that is okay. We're going to leave it 23/5. Remember we said that Algebra 2 is big people math. We are going to leave our answers as improper fractions unless it's a word problem where a decimal would make more sense, or unless there was already a decimal in the original problem. So this is one solution. We will have a second one. So we write the and. Now I need to solve this one. So I also subtract the 1. That gives me 5x equals negative 25. Then divide by 5. So my and is x also equals negative 5. These are my solutions. So I have solved the equation. I must now graph the solution. Now, when I graph the solution for an equation, it's going to be a little bit different than an inequality. My requirements for your number line is you have to have two numbers. So if there are already two numbers, great. If there's only one number, put 0 somewhere on the number line, preferably in the correct place, with the number that you have. So here, my two numbers, negative 5 and 23/5, make sure you put them in number line order. A negative would come before a positive. So they go in this order. And on an equation, the solutions are just equals. So just dots. So a dot at negative 5, a dot at 23/5, and I am now done with my work. Now you can always check your equations by plugging them back in. If I plug in 23 over 5 here, 5 times 23 over 5 is 23, plus 1 is 24. Absolute value of that is 24, minus 5 is 19. And you can check the other one as well. They should both work. All right, 2 little blanks to fill in, 2 examples to go. So the next one, again, must get the absolute value term alone first. So I need to divide both sides by 3 to get rid of this first. So that leaves me with the absolute value of 4x minus 9 is less than or equal to 21. Now, here is the rule for inequalities with a less than or a less than or equal to symbol. The way I like to remember this is I actually say in my head, and yes, I do actually say this in my head. I don't just know everything. I say less than to remind myself that this is an and they become a sandwich. Now, why am I saying they become a sandwich? Hopefully you'll see that here in a second. The rule states that when you have a less than or equal to, we sandwich the absolute value part Again, we take the absolute values away, but we sandwich it between this number and its opposite. So just like over here where we used the opposite, we use the opposite here as well, but it's in a sandwich form. So sandwich between the original number and its opposite. So less than sandwich. Sandwich it between the number and its opposite. Now I can solve, and I know you solved these many a time before. So if I'm adding 9 to get the x alone, I have to do it over here and over here because I have two symbols. So negative 21 plus 9 is negative 12. 4x is what I've got here because these cancel. 21 plus 9 is 30. So now to get x alone, I need to get rid of that 4 by dividing. So I'm going to divide everywhere. Negative 12 divided by 4 is negative 3. X is now alone. Over here, this does not come out evenly. Leave it in fraction form. This is not a word problem. It does reduce. It's 15 halves. So the way that I read this, and the reason we say sandwiched between is because we read this, x is between negative 3 and 15 halves. Now, be careful here. I always get some people who want to say they have to flip the symbol. You didn't divide by a negative. What you divided by was the 4. It's not negative. The original was negative, and that's okay. That's not the same thing. You only flip it when you are multiplying or dividing by the negative number, and 4 is positive, so it's good to go. So we'll leave this. This is our solution. Now we just have to graph it. When we do inequalities, there's a little more to the graph. We're going to start off the same. I've got two numbers, so I'm going to place them in the correct order on the number line. But now I need those open closed circles. These ones, because they have the equal underneath, are closed. So I'm going to put a closed circle on both of those numbers. So it starts off the same, but now I need to shade. Shading, if I'm saying x is between those two numbers, I should say shade the space between. You could test this. If you pick a number between negative 3 and 15 halves and plug it in, it should work. If it doesn't, you know there's something wrong, either with your solution or with your shading. So here is what the solution for a sandwich should look like. So if, when you get the absolute value alone, not always the original problem, but when you get the absolute value term alone, it is a less than, it should always become a sandwich, which means the shading should always be between. All right, last one. This one, also an inequality. Notice that it's already by itself. I don't have to do any division or addition at the beginning. It's already by itself. But this one has a greater than or equal to symbol. So these ones, inequalities with a greater than or equal to, become ors. And what I say to myself, just like I say less than, I say great or. And what that means, this one's going to be written as two separate inequalities, kind of like the equation was written, two separates. So first one looks just like the original. You physically write the word or between them. It's important because or means something different than and. Ands are what you get on the equations. Ors are what you're going to get over here. This situation, on the left side, notice it says they become ors, the first inequality just like the original, except without the absolute value sign. The second with a flipped symbol and switched sign. The left side is going to stay the same, negative 3x plus 10. But on the right side, I'm going to flip the symbol, so it's going to become a less than or equal to, and I'm going to change the sign of this number. So instead of 7, it's going to be negative 7. So the hardest part is making sure you know how to set them up. Great ors, first just like the original. Second one, the left is the same, but flip the symbol, change the sign. Now you're ready to solve. So I'm going to get x alone by subtracting 10. Then I would need to divide by -3. There should be like this red flashing light that's going off in your head. I divided by a negative, which means you have to flip the symbol. -3 divided by -3 is 1. I flipped the symbol because I divided by a negative. Don't forget your or. It is an important part of the solution. And then solve the one over here. So subtract 10 gives me -3x is less than or equal to -17. Again, I'm dividing by a negative. These cancel, so x is alone. Because I divided by a negative, I have to flip. Negative divided by a negative is a positive. It doesn't reduce. We're just going to leave it 17/3. This is our final solution. When we go to graph it, 1 is smaller than 17/3, so put them in that order on the number line. These are both closed circles again. Remember, if there is no equals, they would be open. Less than 1. Less than 1 on the number line would be over here. Make sure that you color the arrows to indicate everything down there is less than 1. Or it could be greater than, meaning bigger than, 17/3. Again, color the arrow to indicate that that should be part of the solution as well. If, when you get the absolute value alone, it is a great or, the shading should always go to the two ends. If you end up with shading that overlaps, so you have shading here and then shading here going this way, you did something wrong. If it's a sandwich, a less than, it should always be shading between. If it's a great or, the shading should always go out to the sides. All right, hopefully that refreshes your memory from what you learned in Algebra 1. So make sure you've got your guided notes to bring with you to class and be ready to work some examples in your group. Have a great night.